So this is the second part of the review, and so we'll start with number 21. On number 21, it asks for us to find what the acceleration of the elevator would be if the student is if the scale reads 520 newtons. So what we have to do there is we have to say, okay, if the scale is reading 520 newtons, that's the force pushing up. The student weighs 500 newtons, that's the force pushing down. So the sum of the forces on this student is 20 newtons. And sum of the forces equals mass times acceleration. So we're looking for acceleration. We know the sum of the forces is 20, so we need to find the mass. Well, if you'll remember, force of gravity equals mass times 10. So we just do 500 divided by 10 and find the mass is 50. And so 50 divided by 20 is 0.4 meters per second squared equals A. And so that answer should be, the answer should be A, 0.4 meters per second squared. And we know it's going up because the normal force is greater than the force of gravity. Number 22, the net force, F, causes M1 to accelerate at a rate A. So F equals M1 times A. And we know that 3F causes M2 to increase at 2A. And we want to know the relationship between the two things. So what we're going to do is we're going to solve both of them for M. So for M1, I get F over A equals M1. For M2, I get 3F over 2A. So the relationship between these two should be 3 to 2, or 2 to 3, depending on which way we lay it out. So it should be 2 to 3 for them. All right. So if we do M1 over M2, we should get 1 over 3 over 2, which would be 2/3, or 2 to 3. So that would be B. The answer should be B. 23. So it's asking us to find, it's got a surface there, and we want to know what component of the vector W would be directed down the hill. So the vector W is this way. We want to know what component of it would be going down the hill. And we know that the angle here is 30. So what we have to remember is that on an incline, the x component is the one that is with the slope of the plane that you're on. So the slope of the incline. And so x, if you'll remember, was different. It was whatever it was, sine, the weight sine the angle for inclines. And so sine of 30 is 0.5. So the x slope should be equal to 0.5 w, which is B. 24. The diagram here shows a ball projected horizontally off a cliff. And so it's asking us to figure out how long it's going to take to hit the ground. So the only thing that we need to know about that is that it's 100 meters off the ground. So if it's 100 meters off the ground, what we can do is we can plug it into dy equals 1/2 ay t squared plus vi yt. And it's important to note that since it's fired horizontally, there is no initial velocity in the y. So this term goes away, and so I'm left with 100 equals 1/2 times -10 times t squared. And the 100 is negative because it's going down. So negative 100 divided by -5 equals t squared. And you get the square root of this, and you should get 4.5 seconds, which is the letter A. 25. It doesn't have an answer choices, but it gives you the answer choices D. So let's just figure it out real quick. So the boat is going this way at 2 meters per second, and the river is flowing this way at 1.5 meters per second. So what we have to do is we have to do the Pythagorean theorem. So 2 squared plus 1.5 squared, square rooted should give us the resultant, and that turns out to be 2.5 meters per second. And so that should be your answer. I don't know whether it was supposed to be A, B, C, or D. The answer choices didn't show up, but it should be 2.5 meters per second. All right, so 26. A cannon is elevated 35 degrees above the horizontal which travels along the path and diagram. The diagram got left out, I think, so if that's the case, sorry. The important thing is that last sentence, though, and it says that if the ball lands 7 times 10 to the second meters away, so the distance in the x is 700 meters, and it was in the air for 10 seconds, then what was the initial horizontal component? Well, Vx equals dx over t, so you can just do Vx equals 700 over 10, which is 70 meters per second, which gives you the answer choice A. Number 27. 27 is how much work is done on a 300 Newton suitcase to lift it 0.5 meters. Well, work is equal to force times distance, so we just do work is equal to 300 times 0.5, and so the answer should be work is equal to 150 joules, which would be the answer choice C. So that should be your answer. 28. It is asking us how much work will a 500 watt motor do in 10 seconds? Well, power equals work divided by time. So we do 500 equals work over 10. 10 times 500 is 5,000 joules of work, which is the answer D. 29. How much would it take a machine to do how long would it take a machine to do 5,000 joules of work, 5,000 joules, if the power rating is 100 watts? So what you want to do is power equals work divided by time. 100 equals 5,000 over t. 100 t equals 5,000. And solve for t, and you should get 50 seconds, which is the answer choice B. And then that's 29. 30. There is no graph. 30 is a bad question. I think the main thing it wants you to do here, what it was trying to get you to recognize, is that if you have a changing force, so if this is force versus time, if the force is changing, in order to do your work equals force times distance, you would need to get an average force for that to plug in here. I think that's what it's asking you to do. I'm going to have to get on to May because I trusted him, but I'm pretty sure that's what it wants you to do. So let me just give you an example. If it started off at 0 and ended at 10, in order to plug, what you would have to plug in here, you wouldn't plug in 10 times distance, you'd plug in 5 times distance, which would be the average force that was applying. Alright, 31. As the time required to do a given quantity of work decreases, the power developed would increase. Because on 31, power is equal to work divided by time. So if you decrease the time, so if time goes down, that's going to make the power go up. Alright, so it should be B, increases. 32. Alright, a 10 Newton force is required to move a 3 kilogram box at a constant speed. How much power is required to move the box 8 meters in 2 seconds? So the answer should be 40. It should take 40 watts, and here's why. So 32, power is equal to work divided by time, but work is force times distance. So power is equal to force times distance divided by time. Power then would be equal to the force, 10 newtons, times the distance, 8 meters, divided by the time, 2 seconds. So power would be equal to 40 watts, which is A. 33. 33 says the graph represents the relationship between the force applied to a spring and the elongation of the spring. What is the spring constant? Well, what we do there is we just pick a point. So I'm going to pick the force equals 8, and I'm going to pick, when the force equals 8, the elongation is 0.4. So x is equal to 0.4. So what you do there is you set up force equals kx. So you do 8 equals k times 0.4 and solve for k. So it comes out 20 newtons per meter is equal to k, which is A, the answer choice A. 34. Which graph represents the relationship between the elongation of an ideal spring and the applied force. So force is equal to Kx. Alright? So if we're trying to solve for this is a linear relationship. There's no squared terms, so it should just be a linear graph. And so it should just be the answer choice B. Remember that, separate note, remember that if it's looking at elastic potential energy, that is 1/2 kx squared, and so the graph of EPE to F or to X should look like a curve. Okay? 35. The diagram pictured shows a spring compression force, or compressed by a 6 Newton force. So on 35 you have a 6 Newton force, and we have a compression of 0.04 meters. And so what we're trying to do is to find K. So force equals Kx, 6 equals 0.04 times K. And so we solve for this and we get K is equal to 150 Newton meters. Alright, 36. Almost done. 36, you just got to draw a best fit line. I'm honestly not going to take the time to do that. I'm sorry. The best fit line, you need to have equal numbers above and below. That's all you need to remember. So like this. And you take the points, your points that you need to take are not these points, they're the points on the line. So you don't take these points, you would take the green points, the points that are on the line. And then 37, using the best fit line to determine the spring force, the answer should be 29-ish if you did it correctly. Alright, so that finishes up the review. I hope this helps people. If you need more help, please let me know.